you are just now catching up with us, I write backward toward you and then reflect it, hence why the words are all backwards by the time I come back and reflect it. Okay, this lovely one is the region is revolved is bounded by x equals 6. Ooh, I can x equals 6. Shoop. Okay. And this is D, by the way. And the line y equals 9. Shoop. Y equals 9. And we are in the first quadrant, just this part of the curve, not over here, not down here. And so this is our region. And it's being revolved around the line y equals 9. Okay, so there's some positives to this. Before we get going too far, I want to draw on my axis of rotation. I almost always make it another color, and I talk about this going to go in this direction. It's not a G, it's an arrow to show it's revolving this way. Before I draw in my axis, my radius, excuse me, you notice this region that I've shaded butts up really closely to all the way up to this line. So that means there's no airspace even way over into here. So that means it's still a washer because there's no airspace. And when you're like, what does airspace mean? You may need to watch the next set of videos that I do on what are called discs, and that'll show you what the airspace is. So when I'm revolving this here is my radius, because this is going to revolve and it's going to end up revolving up here off the top, and it will make a lovely kind of this shape, and I'll do that in blue. And so it's going to revolve, making sort of a trumpet shape all the way flaring out that way. So, but there's no hole in the middle. It's a solid shape, which is why it's a washer. So our volume is still, formula is still pi a to b, the radius, quantity squared, and because it's this way, or because our axis of rotation is like the x-axis, parallel to the x-axis, this is a lovely dx. So I left from my previous work this trading into if I needed to solve it. In this case, because it's dx, I need the variable to stay as x, so I won't actually use this part over here, but I left it from my previous work. Alright, so we're going to integrate. My limits are going to go from 0 to 6. This is our favorite way to do this along the x-axis. We tend to get these correct more. And I'm going to put squared dx. Now, let's talk about what the radius is. The radius starts here, and notice we have a top and a bottom. It's going to go from up here, I'm going to put radius. The radius is 9, that's the top, minus the bottom, and the bottom is, curve. I don't know what I was trying to spell right there, but curve is what it was. And our curve, now notice this negative, has to get parentheses. Our curve is negative 1/4 x squared plus 9. It may be a bit hard to see down there. But actually, I can simplify this a little bit because I have 9 minus 9. So this is going to be negative 1/4, so positive 1/4 x squared. And then 9 minus 9. Hey, my radius is just this because I'm subtracting the two. So I'm going to bring that up, and I'm going to put that in here as 1/4 x squared. Please keep in mind I need to square it, and I still need to integrate it. So I'm going to do one step of simplifying, maybe even two on this one. 0 to 6, I'm going to have 1/16 x to the 4th. I have still not integrated. So now I'm going to actually integrate this, leave my pi out front. Integrate 1/16 x to the 5 over 5, those are being multiplied, evaluated from 0 to 6. At that point, that's a lovely plug-in. X to the 6th over 80, I think. I'm sorry, x to the 5th. 6 to the 5th. I can't even get my words straight. If I were a professional YouTuber, guess what? I would edit and try again, but I am not. So you get a 97.2 pi as your answer. Hopefully that makes sense. So we're doing top minus bottom, but it is still a washer. All right.